go here and then we add this plus this, then we add this plus this on the outer edge, right? So it's like what is the rule for this? If we put it in 0 here, this becomes oh, it's because of this. Okay, so this this value is. So parts minus I minus the last thing that's answer. This is 2, and this is this. Huh. Okay, that took way too long. 590, 1276. We're almost dropped off of the top 100. But sure, let's talk to this problem, I guess, while I try to reconstruct what exactly we're doing. Let's turn this down a little. So, I guess I don't really need this util anymore. Just rewrite it. Okay. So, I think this is like, it's similar to a Pascal's triangle, I think is the concept. But each of these is an independent triangle that we create, basically. So if we start with this one, you can imagine it starting like this. And then the row below it consists of the differences between this and this. So here the difference 3 minus 0. Here it's 3 again, 6 minus 3. We just go all the way down until we get to all zeros, basically. So kind of that's the rule of the game. We don't end at like the bottom of the triangle, we end when everything is 0, aka 1 after everything's the same value. Then we need to, for part 1, play this game called extrapolating out to the right, where we basically add in a 0 here at the end, and then work our way back up and figure out what the value for B should be if we were to add like another entry to the end of this. Maybe there's an easier way to do this by like recognizing what the pattern is. Like maybe each of these diffs is like a series, 10, 11, 11. Okay, never mind. I think these examples just worked out pretty nicely to make them fit here, but we can go through the operations for what we actually have to do here. So I'm gonna leave this as the input reading for now, but basically we'll do for line and day, and then we'll say numbers is equal to int x for x in line.split. Great. So we'll do that, and then we'll just do something here too. We'll clean it up some more after. This is our part 1 answer. So we'll go solve part 1. So what do we actually do for part 1? And then we'll leave the part 2 stuff later. So for each number, what did we do? We went down computing subsequent like diffs basically, and then I think the realization was that all we care about is the last number of each row, because if we have the last number, we know that the number that appears here has to be this plus this. Where are we? We're here. Yeah, so like here we filled in what we created this extra 0 here. So then we have to solve what A is. Well, A is just going to be 3 plus 0, which is 3. Great. What is B going to be on the next one? Well, B is just going to be 3 plus 15, which is this. So all we have to do is say, where are we? While true, because we want to iterate for a while. And then, let's see. I think the easiest way to do this is for A, B, and zip. We'll do it this way. We'll zip up line, everything in the line with like the next values in the line is like this, so that we kind of iterate over pairs like this. This will read a little bit cleaner. We'll go next line like this. We'll say next line is going to be equal to B minus A, right? So that'll create what the next line is going to be here. So we'll start with these numbers like this, and then we'll compute that this is the next thing here. Then what's our condition for terminating? If all n is equal to 0 for n in our next line, we're basically done. So let's break. We also, while we're doing this, want to keep track of the last number we saw in any given row, because that's going to help us go back up the chain, compute what this B is supposed to be out here. So last entries, and we can already seed the last entry here, which is going to be the last value here in our nums. And actually, this is supposed to be nums, and this is next nums. Next nums is here, like that. So we'll call this next nums. We'll say last entries is going to be what are we? Next nums, the last entry there, right? Let's print last entries, and then we'll just see what this gets us, just to make sure I recreated my part 1 code correctly. So do this, we'll run it on the sample input temporarily, and of course we don't need this anymore. We're doing this. Nums equals next nums. So this is what we got out. We got our 0 through 15, which matches this. For the next example here, we got out our 1. Oh, we're off by 1 because we didn't diff 3 minus 0 here. We need to basically take into account the last value that was here as well. So last entries dot depend. Oh, this will be like compute final compute. Oh, sorry. That, let's try to be clear here. The 0 through 15 is this guy, 0 through 15. We want to compute the next thing over 0 through 18. So now we have to compute or extrapolate next column or whatever, column or row. What we're going to do. So for n in reversed, what's the nicest way to do this? We can do extrapolated is going to be this, and it'll start with like this, and And then for n in last entries 1 and onwards, we can say extrapolated. It's going to be, maybe this is too much to type. The last thing we saw in extrapolated plus our next n. I think that should give us the correct answer. So what happens if we print extra here? Oh, we did it one extra time, but we see that 68 here. Why are we seeing it one extra time is my question. Maybe I don't even... Wait, what is in last entries? Why are we doubling up on the final value here? I don't exactly know why for now, temporarily, but we'll just do this. Extra dot append extra. Like extra should have the 0 in it, right? Last. I think it's because my last entries isn't including. Oh, but it is including the 0. What? Oh. This is supposed to be the last value here because we haven't reversed it yet. Is this what we expect to see? No? Ah, that was better this way. Okay. Oh, we're not reversing it. That's what's happening. I want to go 0, 3. Yeah, here we go. So we had to reverse the list to go back up rather than down. So 0, 3, 18 here, 0, 1, 7, 28 here, 0, 2, 8, 23, 68 here. So and then all we care about is that b value here, which is the last thing here. So then we can just say part 1 plus or equals the last value of extrapolate. Great. So that's how we solve part 1. Now part 2, we extrapolate going up this way rather than on the right side. And so it's effectively the same thing. We let's do this. Solve part 2. We kind of did it in a not so pretty way. I don't remember if we actually need all of these things. We need parts, we need diffs. So what are we doing here? I guess what we should be doing is reusing these like the rows that we computed. So maybe last entries should be copy. Like that instead, and we just copy the entire triangle going down. So rather than this just appending next nums, we want to append all of next nums. So we can do it like this, making sure we copy. And then rather than looking for last entries here, now that it's the entire list of things, we actually want to pull out just the final values of it. So this is going to be an entry here, and we want the final value out of each of those. Oh man, I wonder if this works. Print part 1. And let's skip this stuff for now. Jesus, not a thing. Oh. Because we don't have our triangle anymore. Okay, this is annoying. We'll clean up the code later. This explanation is very incoherent. Okay, we're back to here. A couple more undos. Okay. So part 2, let's just completely do the same thing again. So these are nums and these are our nums. List of nums. Why was this line before? I don't understand. Oh. Let's do this again. So now kind of the rule is, since we're starting here, so we create this part of the triangle. We know we have a 0 here. So the difference between this and this, are like, how do we make a 0 here? Well, we need to make 2, minus 2 gives us 0. So then we get this. And then what makes 2 here? Well, minus 2 minus 0 gets us this. Wait, is it? I feel like this is just very similar to this, and I think I overcomplicated it by doing something completely different. So let's see if we can just, because I would rather adapt this code here. Because I feel like there should be a lot of symmetry here. This should be first. Yeah. So I feel like there should be a lot of symmetry here. Obviously now we care about the first numbers, because first entry should be like this. But maybe, I think like these have to get swapped. Maybe it's a minus. Oh wait, no. This is still reconstructing the triangle, so this should all be the same. But then it's here. I think 0, the next number up here is supposed to be this, a value here, minus the last value we saw, extrapolated up. So let's run that and see what happens. Let's print first entries first. Make sure we're grabbing the right numbers. Oh, I forgot this entry was for the very last example. Yeah, so we have 0, 2, minus 2, 5, 5. 0, 2, minus 2, 5, 5. The history values should be minus 3, 0, and 2, and we see a minus 3, 0, sorry, not a 2, and 5, and when they all sum together they get 2. Okay, so I just really complicated part 2, thinking that something completely different had to be done, but it was literally just picking the first values instead of the last values in the entries, and then this equation here was supposed to be n, which is the next value up here, minus what we did here, or minus this guy, rather than this plus this guy, because the diff is going in the reverse order. So completely overcomplicating things actually. We can print part 1 is going to be the answer to part 1, and print part 2 is going to be the answer to part 2. Like that. We don't need to print this stuff anymore. We're confident that this works. So it's going to be 2, and then when we run it on our real code here, we get this big number here, and then this number 118 here. And now there's probably a nice way for us to consolidate these two solutions together, so we only have to build the triangle once. So rather than calling this last entries, let's call this outsides. And we'll make it nums of 0 and nums of -1. And then we'll go outsides dot append next nums. Next nums 0 and next nums -1. Then we don't have to do all of this again for part 2. So now we're just going to be extrapolating part 1 column and then extrapolating part 2 column here. And we only care about the this should be outsides now. So we're gonna reverse that, outsides dot reverse. Don't need to do the reversal anymore. And these are gonna be the first entry. We're gonna go on the left side. Oh wait, no. It's gonna be the right side on here. So that's gonna be for we care about the second value here in the tuple for this one. So extra dot append this, and then we do that. We're gonna say, oh, this already initializes the array, so that actually works out. Outsides 0. On this side, we want the left value of the tuple here, next num 0. So now we throw away the thing on the right when we tuple unpack the values. Then we do this. I think I cleared my clipboard accidentally. So we get 114 and 2 here, and then get the correct values here. So now we only have to build up triangle. We'll do that for lack of better text. And then here we remove our advent of code magic and we read lines like regular people. So for a line in input.input, they should all be the same. And then now if we run this with Python and we go day 9, pass in the input file, we get the correct answer, and we're just reading file input normally. So I think I really overthought this problem, definitely for part 2. For part 2, I thought it was like a completely different operation and the math just didn't work in my head, not realizing that things have to get subtracted because we're going the opposite direction. But yeah, pretty straightforward problem. We really need to get some points. If we don't get points in the next like 2 days, I think we're gonna fall off the leaderboard. So there is pressure to do good. So we'll do that. Yep, thanks for watching.